No, no problem. Okay, sharing my screen. So I have a couple of slides about my project as well, and then a short demo video, and then we can look at the patch and max a little bit more deeply. So this was a project. It's a work in progress, something that I've been working on this semester. I started on it last semester actually, and I didn't get around to it. Robo Cajon is the title that I've landed on. Even the title, it's a working title. But essentially, I started with this idea that I wanted to build a cajon that would listen to me play it on a separate cajon and improvise along with me. And so I do that. So I built a wooden cajon, and I'll go ahead and skip forward to this picture. But I built a box that's the same dimensions as a cajon, a model cajon that I own. And the cajon that I'm performing on is wired up with 2 piezo discs, one at the top. They're taped onto the face here. So one at the top, which is the slap. It's like the equivalent of a snare drum on a cajon, and the bottom one is the tone area, or where you get a bass drum type sound. And essentially, I'm sending these values through Arduino and into Max, and detecting when a slap has been hit or a tone has been hit. And then inside of Max, I'm using some objects from the ml.star package, the machine learning object package by Benjamin Smith, that's classifying the length of the note according to a tempo that's defined by the global transport. And then those values are being used to train hidden Markov models that are then output to a second cajon here that are wired up with little 12-volt solenoids. And so just kind of for a more visual representation, so piezo discs are mounted on to cajon 1. These values go into Arduino, and then sort of Max is the middleman that handles all of the classification and then outputting of the information back into Arduino and then out to the following the robotic performing cajon. And so just a kind of a closer shot of this. There's also something, well, I guess you can see it here, but I had to use a foot pedal, and we can look at this in the patch. But one of the challenges was that the models that I used, they don't learn online, and online just simply means as data comes in to them. So you actually have to send a batch of data all at once, and then reset models, send in the data, retrain them, and you have to do that every time you want to retrain the models. It doesn't just learn as I'm performing. So the foot pedal is essentially, it's a way for me to be able to, for one, if I hold down the foot pedal, then the cajon stops playing, which gives me kind of time to breathe, or gives me time to do something else, like go into a new section or something like that. But then whenever the foot pedal is released, whatever information or whatever notes that I played and that the machine learning algorithm said classified, then get sent and then go and train the hidden Markov models, and then are output. So let me, well, I have this video here, play it. Let me know if you guys can't hear it. This is a short demo. It's a little cheesy. And we can go ahead and stop it there. It's, like I said, it's a work in progress. It works pretty well, sort of well. There's a lot of other things I would like to work on next and continue improving. For one, the box that I built, I just used some scrap wood kind of as a placeholder. I was hoping to maybe build something a little bit better that had more resonance, but this is how it sounds for now. So the main thing inside of Max, and here's the patch, we won't go through all of it, but that it uses time from the global transport. So one of the things that was difficult about getting and this is the area in which the machine learning classification algorithm object is right here in this little box. But in order to get it to recognize particular rhythms as opposed to other rhythms was to compare the time of each note to I'm using the global transport, but the tempo in beats per minute. So the way that I do this, you set the tempo first. So we can set tempo of, actually I think I have to open it here. So I can set 100. And then this tempo value is received to give me the length of the bar at 100 beats per minute in milliseconds. And so that length is 2400 milliseconds. And then I essentially am just using the timer object to detect the millisecond time in between hits. And then all that information gets scaled between 0 and 1. And the reason it gets scaled between 0 and 1 is because I want to take proportions of the measure. So I don't want it just to work at 100 beats per minute. I want it to work in multiple tempos. And so scaling that, so a quarter note in any tempo is a value when scaled between 0 and 1 of 0.25. So it works in all tempos when using the global transport this way. Excuse me. And so here's all of my training data. So I'm training on only certain rhythmic values. I'm training as large as whole notes to dotted half notes all the way down to, I'm actually not training on 16th note triplets. Those aren't connected. It was kind of buggy training on 16th note triplets, and it's kind of hard to tell sometimes if you're playing a 16th note triplet. So the 16th notes are the shortest note values that I'm actually training on. And the way that the particular model I'm using is a multi-layer perceptron, and it essentially all it means is that it has at least 3 input layers. So it has an input layer, then there's a hidden layer, and then there's an output layer. And I am using let me see, I forgot what the arguments say. So the first 2 arguments are input and output size. So these are the values that it receives. So 2 input values, you send it 2 input values, and then it gives you 3 input values back. Then the next argument is the number of internal layers. So this is the number of layers in between the input and output layer. And then the number of, oh, sorry, I got that backwards. So the third argument is the internal layer size. So this is the number of nodes per layer, and then the final argument is the number of internal layers. And I just used the default 8 nodes per layer and then 2 internal layers, and that worked just fine. In fact, anytime I changed it, it wasn't classifying correctly. So this seemed to work best. But when you send it information to classify, since I've specified 3 input values and 2 output values, all of the training data sets have to be at least 5 numbers long. And what this says is that each message of 5 values, the first 3 are the input values. So these are the inputs that the algorithm receives. And then the 2 output values are the 2 output values that are supposed to match whenever the input values are received. So in this case, so this is a slap, a whole note slap. So the top part of the cajon at a whole note value of whatever the tempo is according to the global transport. So whenever this receives a slap that's a whole note, it's supposed to classify. It receives this 101, and then it's supposed to give me back a 1 and a 16. And so that's essentially the way this works. I do have a couple of other classifications here. So if some of the notes are too short, I don't want it to, let's say, double trigger or classify a note length that's really, really short. So I'll essentially just classify notes that are shorter than I want to classify, or longer than I would like to classify, so longer than whole notes, and I'll just give them a class of 0, and it's basically a way for me just to discard data that I don't want being output and affecting the performance. So whenever this thing is trained, you can set the number of training repetitions and then train here, and then it will give you some average training error. And the average training error is essentially just how accurate this thing is going to be classifying. And so whenever it receives these values, it gets classified. And then what I'm doing, one of the things that's nice about the way that I'm doing this is I'm rounding all of the values, all of the output values, and I'm essentially rounding them to either whole notes, 16th notes, dotted eighth notes, and to all of the original values that I wanted to classify to begin with. So I'm discarding all other data by doing that. And so this information then gets stored inside of a bag, and where it just collects. And then whenever I press the foot pedal down, just connect it over here, this resets all of the Markov models. I have a bunch here that I can choose from. I essentially just use this hidden Markov model. It seems to work the best. But this resets all of the models, sends the information, whatever the contents of the bag are, to all of the models, and then trains them. And this happens pretty fast, assuming that there's not 1,000 or so different values inside of the bag at any given time. The fewer number of numbers there are, the less time it takes to train, and then the faster it works. And so this information, then the Markov model uses it and looks at it and says, okay, these particular classification values I've received, and in this particular order, and so it outputs them. So if I play more eighth notes than I do quarter notes, then this thing will usually output more eighth notes than quarter notes. And then those values get rescaled back into the millisecond values from the transport. So if this receives a 0.25 or whatever 2.25 would represent, so let's say it receives a 16, and 16 just means that it's the value of 1 here in the first place just means slap. So if it receives a 1, then this is a slap that's a quarter note length, and this essentially just gets multiplied by the length of the entire bar in milliseconds, and then that sets metronome. And so that comes out, boom, and then determines whether or not it's a slap or a tone, and then that info goes back all the way up, and then back into the serial object, into the Arduino, and then the solenoids get triggered. So in a nutshell, that's kind of the way it works. There's a lot I kind of want to fix, and after having performed with it, I only performed with it the one time while I was recording, but there's a lot I kind of would like to tweak about it, and maybe get some other instruments too. So